Did you know Banksia shrubs can withstand extreme heat and fire up to 700 degrees Celsius? You're listening to Wild Engineers, decoding nature's intelligent designs in your coffee break. Let's dive in. During bushfires, extreme heat arrives in seconds, causing firestorms, mass exodus, burned landscapes and chaos. Hi, I'm Melanie Farmer, and today's question is, how does nature protect from fire? Imagine you are a shrub in the wilderness. Bushfire temperatures can climb to 1,000 degrees Celsius. Flames can reach 20 kilometres high as they race through the canopy, sometimes more than twice in one event. Animals run or burrow underground, birds fly out, but shrubs and trees can't move. To protect from fire, the Oldman Banksia shrub, or Banksia serrata, stores its seeds inside thick, woody pods called follicles. Under normal conditions, those pods are rigid and sealed, but when temperatures rise to around 54 degrees Celsius, something changes. A wax inside the follicle undergoes a phase change from solid to liquid. As it melts, the wax flows into micro cracks and gaps that form under the heat. It self-seals the structure at the exact moment damage would normally accelerate. As fire intensity increases, thick walls slow heat transfer and air gaps add insulation. The wax continues to melt and re-solidify repeatedly. This process can repeat ongoing through multiple bushfires over 17 years. Pretty cool. Even when external temperatures exceed 600 degrees Celsius, the temperature near the seeds has been tested to remain under 100 degrees, below lethal limits. The fire passes, and although the event can compromise the shrub, their critical component, Banksia pods, remain protected. Researchers wanted to know if this strategy could work beyond plants in our buildings. In laboratory testing at the Max Planck Institute, researchers immersed planks of pine wood into a Banksia-equivalent liquid carnauba wax heated to 1,008 degrees Celsius for 10 minutes until air bubbles disappeared. Later, when heated, the wax melted and flowed into newly forming cracks, sealing them before heat and oxygen could penetrate further. The result in these test conditions was a material that was less flammable than pine wood alone. When the samples cooled, the wax hardened again, offering the possibility of continued reuse, just like the Banksia. A notable advantage is that this solution is heat activated without the use of sensors or human intervention. We started with this question: how does nature protect from fire? Here, nature's strategy was to protect internal systems by adding a waxy material. The mechanism involved treating building materials with a phase-changing liquid from solid to liquid, self-sealing cracks when naturally activated, and controlled heat protection on a loop in lab conditions. Next time fire becomes a design constraint, perhaps we could consider if cracks could seal themselves when heat arrives to delay ignition, or prevent fire entirely by just adding a material like the Banksia does. That's wild engineering. Thanks for listening. Stay wild, and I'll see you next time. That's it for this episode of Wild Engineers. If you're inspired to apply nature's intelligence in your own work, check the show notes for more detail. If you know someone who could benefit from this episode, please share and help us redesign our world inspired by nature.